Guten Tag allerseits. 9-9. Lasst uns das nochmal versuchen. Guten Tag allerseits. Perfect. Mein Name ist Donovan Brown, Principal DevOps Manager für Microsoft. Vielen Dank für den Beitritt zu mir heute Morgen. Ich wurde in Deutschland geboren und liebe es, zurückzukommen. I love coming back. My colleague does not speak German, so I'm going to start speaking English. And as you can see, I don't speak German very well either, so English is going to be better from now on. Abel and I work for a team called the League of Extraordinary Cloud DevOps Advocates. We are 5 practitioners who cross dev and ops, and our entire goal in life is to make sure that you can run your workloads in Azure. Doesn't matter if you use VSTS or not. If you have a workload that you want to run in Azure, I have someone on my team that can help you do it. If you want to run on Linux or Mac, we have Jessica. If you want to use Chef, I have Steve. If you like Octopus Deploy, I have Damien. And if you like VSTS, I have Abel. And I run across a lot of that stuff. So if you need our help, you can actually use that hashtag on, it's a little easier to see here, on Twitter. If you use that hashtag, it lights up a room in our team room, and our entire team will run to that tweet and see if we can actually help you. If I can't help you, I will literally find the person in Microsoft who owns the feature you're asking me about and add them to that thread. We are very, very serious about making sure that we engage with our customers. When it comes to Twitter, we're aggressive like Trump. But we don't act like a 2-year-old, so we're actually going to help you instead. So we're here to talk to you about DevOps. If I were to ask everyone in this room to define DevOps, I would get a different answer. So what we're going to do is we're going to level set really quickly on what we believe DevOps is at Microsoft, so that when I say DevOps from this point forward, you know exactly what I mean. We sum it up in one sentence. DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. The most important word is value. It is not about getting to the end of your product backlog. It is not about that next feature. It is about delivering value to your end user. Doesn't matter if it's from a Mac, doesn't matter if it's from a phone, doesn't matter if it's Java, doesn't matter if it's .NET. The reason that you're writing that software is to continuously deliver value. And that's what we do internally at Microsoft. So what Abel and I are going to do with you today is share with you how we actually went through this transformation ourselves here at Microsoft. But before that, we're going to have a little bit of fun. We're going to talk about how I see Microsoft. I happen to be a race car driver, so I kind of have an affinity towards racing cars. And I have a video that I want to play that I think sums up what your life is before and after you implement DevOps.
But Holland comes in for a pit stop. Time to refuel and change tires. Lou Moore himself changes the tires. Only 4 crew members, including the driver, are allowed to work on the car. It's a tense time. Holland stays in his seat, anxious to get away. Let's watch. Tires are changed at last. A crewman polishes the windshield as Holland moves away just 67 seconds after he stopped.
When I saw that video, I tweeted it out and I said to myself, that is DevOps before and after. We are writing software and deploying it at a rate that we've never been before. But what was really interesting about that is that I got challenged if the second pit stop really added more value than the first. And to me, it was like, of course it did. But one person said, but Donovan, there were so many more people in the second video. Another person pointed out, but hey, in the second video, they didn't even refuel the car. They didn't add any value to the first pit stop. What was really interesting is I thought about it for so long that I ended up writing an entire blog post on why I believe that this video is a perfect representation of before and after DevOps. Let's address the larger number of people. I would argue that today there are more people involved in deploying software than even 5 years ago, let alone 10 years ago. You have security, operations, quality, compliance, auditors, the developers. Everyone now wants to put their hands in this bucket of clean, feels that they have something to say about how we're supposed to be deploying our software into production. So I think this is a perfect representation of the number of people that are now involved in deploying software. But what was really interesting to me is that when I saw these people, in my mind, they weren't people. They were automation. They were specialized tasks that allow us to do something very specific when it comes to DevOps, and we do that all day long. We have source control, continuous integration, unit testing, code coverage, security scans. That's what I'm seeing here. I'm not seeing people. I'm seeing those services and those tools that we link together to build a really effective pipeline. When I talked about the definition of DevOps, I said value is the most important word. And you have to monitor what you do in production to make sure that you actually delivered value. These two gentlemen never move. They are literally just monitoring a pit stop that only took 2 seconds to see how they can shave off another thousandth of a second, another tenth of a second. It's amazing that you have to make sure, and that's an exact replica of what we do in DevOps. You should be measuring everything that you do to make sure that you're actually having an improvement. So to me, these weren't people. These were automation, which is what we apply every day inside of our practice. The second thing was Donovan. They didn't refuel the car. But let's take another short look at that second pit stop. That's halfway through. Another 37 seconds was spent changing the rest of the tires. So even if we were to change the fuel or add the fuel at the same rate as they did in the 1950s, we would have still been done in half the time because they focused on what hurt most first. And that's what you should do when you're implementing DevOps. Focus on what hurts most first. And it was changing the tires. It took them 67 seconds to change 2 tires. But in the second video, we changed all 4 of them in 2 seconds. Another thing you have to focus on is that it wasn't that they did not fuel the car. It was that they did not have to fuel the car. You understand the difference there? They did not have to add fuel to the car because they had shifted left all the technology necessary to make the car more efficient, to allow the car to go further on less. Trust me, if that car needed fuel to finish the race, they would have put fuel in that car. They did not need to fuel the car. You're looking at it completely wrong if you think they cheated or they took a shortcut. No, they shifted left. They put all the technology in the car so they did not have to refuel the car. So instead of doing things like they did in the old days, they were able to drastically switch this to where it just happens instantly, right? So that's what I want people to focus on. And I think this is a really good representation of when you're doing DevOps right, you go from what we had before to something that looks like this. That's exactly what we did inside of Microsoft. When we started our DevOps transformation, we used to ship software every 3 years. 3 years in a technology company. How in the world can you imagine that you're going to be able to make decisions 3 years before you actually realize the results and know that you're going to be right or not? Sir, has anyone ever used TFS 2005? Anyone? I'm very sorry for that. I'm a little sorry for 2008 and 10 and 12. But 2013, we kind of figured it out because we realized you couldn't be away for very long. But you're saying, Donovan, turn around and look. That's a 2-year gap there again. Actually, it's not. In 2013, we started shipping updates every 3 months. And we continue to do that to this very day. If you're using Team Foundation Server, the on-prem version of what we deliver, you get an update every 3 months like clockwork. But that still wasn't fast enough for us. There's a sister product to this one called Visual Studio Team Services, which we ship every 3 weeks without fail, without miss. And what's really nice about that is Visual Studio Team Services is actually versioned, planned, tracked, and deployed using Visual Studio Team Services. We dog food everything that we do here at Microsoft. So what we had to do is we had to change from the waterfall mentality over to a more agile or scrum methodology. So what we do is in our organization, we basically have program managers and we have engineers. Program managers play the role of the product owner. They own the product backlog, they decide what goes on there, and what priority it has. Then what we do is we take 10 engineers and we pair them together and we create something that we call a feature team. We have over 50 feature teams across the world. We have them in Redmond, where we're headquartered. We have them in Raleigh, North Carolina, and we also have them in India, in Hyderabad. And each one of those teams owns a feature of Visual Studio Team Services. They are all merging into one master branch, over 500 engineers every single day. Now what we do is we put them together though. So even though we have 50 teams spread across the world, if you are on the same team, you are in the same room. This actually really helps with your communication. If we need to have a daily stand-up, everyone just stands up because we can hear each other. We answer the 3 questions and we sit back down again. If one of these engineers has an issue with an API written by another engineer, they don't have to find them on Slack. They don't have to set up a Skype meeting. They simply just roll their chair around, talk to that individual, and then get the problem solved immediately. If you need to have a long-running conversation, outside of this room are 2 smaller rooms that have doors and whiteboards so that you can go back in there and have a longer conversation if you need to without disturbing everyone else in your group. They stay together for about 10 to 12 months before we actually tell them you can go somewhere else and work on a different team if you want to. But if that means moving to another country, that's what you're going to have to do. We call it the yellow sticky exercise. Each of the 50 leads get up and tell you that, hey, you want to come work on Visual Studio Team Services, get support, right? It's the coolest thing ever. You're going to revolutionize the world. And they give this big pep rally about why their team is so cool. And then all the engineers write their name on a yellow sticky and they put their names underneath the engineers that they want to work with. 80% of the guys or women go back to the team that they were already on. The reason why is because there's a culture in each one of these rooms. This room is one of the nicer rooms. It's quiet, people have their headphones on. The room I was in was not so quiet. We used to have these Nerf guns. You guys have Nerf guns here? Literally, when they wanted to blow off steam, you would just see bullets flying through this room. So you had to go in there armed every day, because if you didn't have a gun, you were the one getting shot. It was just that simple. But what's really interesting is each room is allowed to do whatever they want. We call it aligned autonomy. They're autonomous, they're self-managing, but we align them with our 3-week sprint length. No matter what team you're on, the sprints start and stop at the exact same time. They're always 3 weeks long. That's the way we can keep 50 teams all in sync. Can you imagine 50 Scrum teams all sprinting at a different cadence, trying to rely on each other? It'd be a nightmare. You're free to do test-driven development if you want. You're free to do pair programming if you want, but you are going to come in 3 weeks and be ready to deploy your software. What you do within that 3 weeks is completely up to you. Aligned autonomy, okay? We have 3-week sprints. Some people always ask me, how did you get the 3 weeks? The way it was explained to me, it was the Goldilocks syndrome. Goldilocks is a child's book that we read in the United States. And what happens is some things were too small for her and some things were too big for her. And then this one thing was just right. It's exactly what happened to us. We tried 2-week sprints and they felt too short. We tried 4-week sprints and they felt too long. And then we got the 3-week sprints and they felt just right. Right? And we've been sitting there ever since because that's the pace that allowed us to have the ceremonies that you need in Scrum, but not feel like you're in meetings all the time. Right? It was this nice balance and we've been running that way for a really long time. So you might be asking, if it's 3 weeks, then what's this area here? These dark areas are the deployment of VSTS on top of itself. It happens automatically, it's completely automated, and it takes about 10 days for us to deploy from one ring all the way out to ring 5. So we have 6 rings of deployment that we go through because we practice safe deployment. And what we do is we basically let that code flow through the pipeline while we start our very next sprint. We never stop. Next question is, how does you break down the sprint? First, we have our sprint plannings. For the first 2 days, we're basically hardening up the task, making sure our estimates are solid. We sprint for 3 weeks, and then we're done, and everything that needs to be deployed is ready for deployment, and the deployment automatically starts. Next question I always get asked is, how in the world do you keep 50 feature teams all across the world in sync? How does Team 1 know what Team 48 is doing? Believe it or not, we use email. Every PM writes an email saying, this is what my team is planning to do over the next 3 weeks. At the end of that 3 weeks, we get another email that says, this is what my team was able to do over the previous 3 weeks. And here's a short video showing you exactly what my team was able to deliver. It's basically a way for us to sit in everyone's team reviews without actually having to be there in their sprint review. What's also really cool about this is that video, you cannot use special effects. You cannot do any After Effects. The software has to actually work, which is kind of cool because now the developers have to finish the code several days before the end of the sprint so that their PM has an opportunity to record the video. We didn't actually anticipate that side effect. We just thought we needed to wait for it to share, but it's actually a forcing factor to make them get stuff done sooner so that it can be a part of the actual video itself. What I like about that is that the developers and the PM have an opportunity to review the code while they're producing the video to make sure it meets all their expectations. And if not, they have a couple days to polish it before they actually have to ship their code. So it's been a really powerful concept for us. So this is what it actually looks like. If you've ever used TFS or Visual Studio Team Services, you recognize that. That's just a work item query. And if you click on those links, you can actually go read the details of the items in the work that the team is planning to work on. At the end of the sprint, we get another email, and that email is this one that actually has the video in it that we can actually sit down and watch and make sure that we can keep up with what everyone else on our team is doing. Last thing I want to talk about before I bring out Abel is how we do our planning. We know better than to do 3 years worth of planning up front, but we still have to have that vision. And we basically cast a 18-month scenario. We basically say today is January 1st, 18 months from now, given everything that we know, where do we believe our software and our project should be? If we only do 60% of that, we're going to be ecstatic 18 months from now. We then break that 18 months down into 2 6-month seasons. One of the seasons lands at Build, which is one of the most popular conferences in the world, sells out in about 30 seconds, and it usually happens around the May timeframe. We have another conference that happens in November called Connect. Those 6-month seasons land at Build and Connect. So when you watch those conferences, all those big ideas that are coming out is because we planned them just like this. We then take that 6 months and we break it down into the 3-week sprints. And you'll notice that 3 of the 3-week sprints are kind of highlighted. At every third sprint, the teams that are related to each other come together and have sort of a scrum of scrums to make sure that they all understand what their teammates and their other scrum teams are actually doing so they don't get too far away from each other. 6 months later, we basically cast a new 18-month vision. 6 months in our industry is a very, very long time. We cannot assume that what we decided 6 months ago is still what we need to be 18 months from the future. So we basically rinse and repeat this all year long. So what I would like to do now is bring out Abel Wang, who's going to show you how we do planning here inside of Microsoft. Everyone, here's Abel.
Good afternoon, everyone. Thank you. Now, unfortunately, I don't speak any German. American public schools, I'm very sorry. So planning. At Microsoft, we actually use Visual Studio Team Services to plan, build, and release Visual Studio Team Services. Now, because we use VSTS for planning, we're able to track any unit of work for our project. Let me show you how we do it. Now, what you're going to see here, this right here is my personal dashboard into VSTS. Every developer can have their own personal dashboard, and it's fully customizable. So I picked dashboard widgets that will show me the health of my project, as well as work that I need to do. Now, the main means of planning in an agile world is through backlogs. Now, what's a backlog? A backlog is nothing more than a wish list, right? It's a wish list of everything you need and everything you want for your project. And it's an ordered wish list. So the most important things, those rise to the top, and the least important things sink to the bottom. Now, for VSTS, we use 3 levels of backlogs: scenarios, features, and also stories. Now, scenarios is the big picture, right? That's when we break down the work that we need to do in huge chunks, where each scenario, we should be able to finish a scenario in 18 months. Next, we take our scenarios and we break those down into features. There's still big chunks of work, but we should be able to finish features in 6 months. Then we break down our features and we break them down into stories. Stories are smaller. We should be able to finish a story within a sprint. And our sprints are 3 weeks long. There are some teams as well that take stories and break those further down into tasks. And tasks are small chunks of work. Tasks need to be small enough that you can finish it within a day. So we have 3 levels, right? Scenarios, features, and stories. And these backlogs, they're great. They're great for adding new work, for prioritizing work. You can just drag and drop the work items, but I'm not going to do that because this is live data, and people will get really mad at me if I change the order. You can even reparent work, and it's great for looking at how much work is left. But backlogs are not good at tracking work, and that's where these Kanban boards come in. The Kanban board is a visual representation of the work that your team is doing. And this Kanban board is fully customizable. So we customize the columns. You can customize the different swim lanes. We even came in here and customized what data is shown on the cards. We've created custom style rules. Let me show you one of our style rules. So what I mean by that is we have a rule now where if a work item is flagged as need more info, we turn that card yellow. Or if we have a work item that's flagged as a hot fix, we flag that as a nice pale pink color. So now as a developer, I do work from this board as well. Because when a work is assigned to me, what's the first thing that I do? I create a branch for myself to work in, right? So I just come into the work item, and from the work item, I just say create a branch. And bam, just like that, I've now created a branch for myself to work in. And we've automatically linked that work item to the specific branch. So now all subsequent check-ins to this branch is linked back to this work item. So tracking our check-ins to the work, that happens for us automatically. Now, another benefit of doing branches this way is, well, I don't know what your Git repos look like, but our Git repo, we have millions of branches. All right, maybe not millions, but we have a lot of branches, right? Anytime a developer needs to do something, the first thing they do is they kick off a branch. Now, it gets cluttered and it starts getting hard to figure out what that branch is for just from the name. But if it's linked to a work item, we immediately know what that branch is for. So now as I do work, I'm just going to take this work item and walk it across the board. But once again, I'm not going to do that. Real data. Don't want to change real work. So just like our backlog, we have boards at the stories level, at the feature level, and all the way up to the scenario level. So now anybody can come in, and whatever level they want to look at, they can see what our team is working on. So this is great for our team, but how do we track work across multiple teams? Remember, Donovan told you, the Visual Studio Team Services team, that's over 50 teams. So how do we track across all these different teams, and how do we make sure the teams are aligning for our releases? That is where the deployment or release plans comes in. Now, a release plan, this is a timeline, right? This is a timeline where on this timeline, you start adding all the teams that you want to track. And each team is their own row. Now, we then subdivide the teams up into the sprints that they're doing. And if I opened up the team row, you'll be able to see all the work that they're doing in the sprint and the state that they're in. Now, I wish I could open up this row and show you because it looks really cool, but I'm not allowed to do that because this is real data, right? So we're about to release new features, and we haven't announced it yet, so I am literally not allowed to click that and open it and show you guys. But this is how we plan across multiple teams to make sure teams are aligned correctly. So all of this right here, this is how we do planning for Visual Studio Team Services. Now, planning in an agile world, it's a little bit different than planning for a traditional waterfall project. We're collecting different data. We're collecting different metrics. And in Visual Studio Team Services, we have a set of tools that makes this really nice. The backlog, the Kanban board, these release and delivery plans. And you know what? These tools, they work great for small projects of just one team, all the way to really large projects like Visual Studio Team Services of over 50 teams. Thank you.
Thanks, Abel. So what we're going to talk about now is how we address quality. When you have 50 feature teams working on one code base, trying to ship every 3 weeks, quality is imperative. There used to be a saying, fail fast. That way you can learn really quickly and then recover. We don't want to fail fast. We want to succeed fast. We want to deploy it, and we want it to work the first time that we deploy it. And the only way that you can do that is to focus on quality. Historically, we would go through something called a code freeze. Has anyone ever had a code freeze before? Developers in the room? You know what that means, right? Please stop typing, right? Because if you keep typing, you'll keep creating bugs, and we got to get to the bugs you've already written. So what you do is you have your developers, please get your hands off the keyboard, get all your code over to the QA team, while you guys go have a party talking about how great you were. They're logging bug after bug after bug. And what's going to happen is after the party, you find out that you have so much technical debt that you now have to do a bug bash. And you basically try to burn down all that technical debt and then ship it as fast as you possibly can. It usually looks something like this. The amount of technical debt that you've incurred, you don't know until you get the data back from the QA team. Depending on how you've written your software, that could be a short period of time or a long period of time. It could also be the difference of how long has it been since the last time you had a code freeze. If you do this every 6 months, oh my goodness, the amount of time it takes the poor QA team to catch up is an inordinate amount of time. And there's no consistency here, depending on what it was you tackled last, because none of the developers are writing tests. You remember these days, all you did is you got to a code freeze, you coded as fast as you could, you never wrote a single test, and then you gave all this untested code over to QA, and you waited. And what you got back was technical debt. Well, we have an engineer at Microsoft who looked at charts like this. Buck Hodges said, this is not okay, because I want to be able to ship every week. Basically, let me put it in a different way. I want to always be a week away from shipping. That means I want to be able to say on Monday, guys, we're shipping on Friday, and all the young ladies and young men get together, and a week from then, they're ready to ship. You can't do that when you have a chart like this, because you have no idea when you're going to have another big peak or big valley in there that all of a sudden you have more technical debt than you're supposed to. But what if we do that concept about shifting left? What if we force the developers to write tests sooner, to be able to track the bugs more early? That way we can take something that used to look like this and turn it into something that looks like this. And what we decided to do was, he did some math. So Buck Hodges decided to do some math and determine how quickly can my team burn down bugs? And after doing the math, on average, a team could burn down 1 bug per engineer per week, which ended up being like 5 bugs a week. So if you didn't have any more than 5 bugs on each team, that team would be ready to ship within a week. So if you start writing your test earlier, running those tests and identifying that you have bugs, you can keep a much closer track on your technical debt. And as soon as the team had 6 bugs, someone had to stop what they were doing and pay down that technical debt. We watch this metric very, very closely. We call it the bug bar. And this is an old chart, because I think this only has like 35 teams on it versus the 50 we have now. But on this right-hand side here is a column that we highlight. And here we basically tracked, on average, how many bugs were each team actually carrying. And if it went over 5, we basically would go and have a discussion with them. We do not use these numbers to punish our teams. We use these numbers to learn how we can enable and empower our teams to do better. If they failed to stay below the bug bar, maybe they need more training. Maybe they took on technology they had never known before. Maybe they were simply being more aggressive than they needed to be. But we need to understand so that we can empower our teams to stay below the bug bar, because it's crucial for us to be able to ship at the rate in which we ship, that this number stay below 5. But do not measure and then punish your developers with it, because they will start to game the system. They're developers. This means they're very, very smart. And if you force them to game you, they will. So we simply do not punish them for having these numbers go above it. We simply inspect and adapt. It's the mantra of Agile. You inspect and you adapt. We're inspecting right now, and if it goes over set 5, we will adapt and make sure our teams are successful. So do not, by any means, punish your developers with this information. But quality was crucial for us. We used to have 27,000 automated UI tests, none of which ever passed all at once, ever. There is not any record on ever it all working. So think about that. If they never always pass, who listens to it when it fails at all? No one, because you always know something's going to fail. There's 27,000 of them. I'm not going to go see which one it was. I just know that it's never, ever, ever green, so I just ignore it. So what's the point? And we had to figure out how can we actually have that signal mean something to us. And not only were they slow, not only did they never pass, they were also very difficult to maintain. If you've ever done automated, it's very, very hard. So what we wanted to do is, again, shift it left, put that testing in the hands of our developers through the concept of unit test instead. Which means we had to re-architect the way that we wrote our software to make sure that we could actually get to the nooks and crannies of it with unit tests. Because if you're putting everything on an on-click method in a form, there's no way to get to that stuff unless you click that button on the form. But if you re-architect that and put that in a class library, then all of a sudden, I can now get to it through a unit test, which is much easier for us to write, executes much faster, and we can do it part of our CI system, right? So that's what we were trying to do when it comes to managing our technical debt. It was crucial to that. And we've made huge advances of that here at VSTS team. And what I want to do is invite Abel back on stage to show you how we measure and track our quality in the VSTS team. Here's Abel again.
How we manage quality in an agile world, it has to be different than how we manage quality in a traditional waterfall world. For one, we're iterating much quickly, right? So we don't have the same amount of time. So we're spending less time testing. Now, I'm not saying testing is less important. In fact, I'm saying the opposite. In the DevOps world, testing is even more important because with all the fancy CI/CD pipelines that we built out, if we are not managing our quality carefully, that means we're just pushing bugs into production super, super fast. And nobody wants that. So what's the difference, right? Back in my day, and I'm old as dirt, I'm really, really old. So back in my day, at Microsoft, we used to deliver software once every 3 to 4 years. So what we would do is we would spend 1 year getting requirements, we'd spend 1 year coding like mad, then we would spend a year, sometimes 2 years, doing end-to-end functional testing and burning down a mountain of bugs. And in today's world, we no longer have the luxury of spending weeks, if not months, doing end-to-end functional testing. So how do we manage quality? Let me show you what we do in the VSTS team. So for us, what we did is we moved away from our functional testing and our automated UI testing, and we shifted most of our efforts into unit testing. Now, I'm not saying we don't do any functional testing or we don't have any automated UI testing. We have some, right? We still have some, especially for smoke test. But the bulk of our effort is in unit testing. So what you're seeing right now, this is our quality dashboard, where you can see all the tests that are running, our continuous testing for every build, for every release, for everything. Now, another way that we maintain quality is that we are forcing every single developer check-in to go through a pull request. Every single developer check-in. So what's a pull request? A pull request is like a code review, right? But in this pull request, they also have to build and run all the L0 unit tests. Now, on the average, every day we run about 600 or more pull requests. And remember, each one has to build and they have to run all of our L0 tests. L0 tests, that's a subset of all the tests that we have. When we run all the tests, do we ever? Absolutely. We do that when we merge into master. But for our pull requests, let's go ahead and take a look at one of our pull requests. Check this out. This one passed, and it ran 70,576 tests. So let that sink in for a moment. Every single pull request, every single developer check-in has to pass 70,000 plus unit tests. And we do all that in less than 7 minutes. That's how we maintain quality. Now, another way that we maintain quality is how we release. So we don't release new bits to the entire globe all at once, right? So VSTS, it's a service that services the entire world. What we do is safe deployment, where we deploy to rings. So we deploy to ring 0, ring 1, all the way up to ring 5. Now, ring 0, that's us, that's engineering. So the first thing we do is we deploy for ourselves, all 500 of us, and once it's deployed, we let it sit there for about 24 to 48 hours. We let it bake. And while it's baking, we, engineering, all 500 of us, we start using it. And as we're using it, we are gathering telemetry. And if we find issues, or telemetry finds issue, that release, bam, it stopped. But if everything looks good, it will flow on over to ring 1. Now, ring 1, that's our friendly. So that's our MVPs, that's our super, super friendly and forgiving customers in case things go wrong, right? So the same thing happens. It sits and bakes for 24 to 48 hours, and while it's baking, people are using it and telemetry is gathered. And if anything flags as bad, it gets stopped, but if it doesn't, it flows on over to the next ring, ring 2. So ring 2 is our smallest scale unit, so that would be Brazil. So then our Brazilians, they start using it, they flag if there's any issues, or, you know what, our telemetry is gathering as it's going on, and if everything looks good, it flows to ring 3, then ring 4, and eventually to ring 5, which is the entire United States. So that's how we maintain quality, right? But quality, man, it's hard. Quality is really hard. It has always been hard, and it is still hard. To this day, quality is still hard. But with the practices that we do, we deploy slowly, carefully, and safely. And in this fashion, we're able to maintain quality. We had to shift how we do things. We no longer can just do end-to-end functional testing. So the way that we shifted was away from functional and automated UI testing to unit testing. And for us, unit testing is our first line of defense, and it's our best line of defense to maintain quality. Thank you.
Hey, Abel, you left my slides, man. You ruined the whole show. He's back there patting himself on the back. There we go. Quality. We not only measure the developer's quality, we also measure the quality of the system while it runs. Remember I talked about the 2 people that didn't move, that just monitored the pit stop, learning from it? We measure everything, not only the bug bar, but we also measure every LSI, which is short for live site incident. That means that our system has done something that it wasn't supposed to do, and our customers are no longer able to yield the value that they're supposed to. This is not pointing a finger at operations. On the Visual Studio Team Services team, if you wrote it, you run it. What that means is that the developers who actually wrote the software that is running in VSTS are the ones on the bridge when we have a live site incident. It's no longer someone else's responsibility to deal with the bad decisions that I've made as a developer. Some person asked us the other day, well, how do you know that those unit tests are actually good unit tests? Because if they're not, we wake the developers up at 3 o'clock in the morning and we put them on a bridge to fix the system because they wrote a flaky unit test. When you actually make the consequences paid by the people who made the bad decision, they stop making those bad decisions. People always ask me, it doesn't sound like you have a QA team anymore. We don't. We have engineers who are responsible for the quality. He says, but Donovan, developers make the worst testers on earth because they only test their software the way that it was designed to be used. I was like, I understand that. Next time they do that, wake their asses up at 3 o'clock in the morning, see if that doesn't fix your quality. It did for us. So our developers are on a rotation. If you're on one of these 50 feature teams, at some point or another, you were on call for VSTS. And if the system went down, you had to get your butt on a bridge and start troubleshooting this particular problem. First thing we have to do is mitigate the problem, which means we have to get the service back up so that our customers can start yielding value in using it. The next thing you have to do is do a root cause analysis, which is determine why the system went down so that we can stop it from ever going down like that again. You simply can't restart the machine. If you reboot a machine after an error, you have just guaranteed that that problem will happen again because you haven't fixed anything. You have to do a root cause analysis. After we determine why the system failed, we add a product backlog item to our backlog that says this is how we're going to fix this long term that makes sure that this never happens to our customers again. The final thing that happens is Brian Harry writes a blog post and posts it publicly on why we had an LSI and explains to you exactly what failed and what measures we're taking to make sure that that never happens to our customers again. We're completely transparent. Trust me, those blog posts are a blow to our ego. You do not want your boss having to apologize for a failure that you made. So wake them up and pay a consequence. And our pride was the consequence when we had these LSIs. We measure how long it took us to detect it. We determine if it was detected by our telemetry or by a user. If our telemetry did not let us know, we simply go back in and fine-tune our telemetry. We should know that there's a problem with our system before you know there's a problem with our system. And if not, we're monitoring the wrong things. And we determine that based on how we got the LSI, how we detected it, how long it took us to mitigate it, and how fast we were able to put a root cause analysis fix to it as well. So this is something that we take very, very seriously. Again, you have to measure, but we only do this so that we can get better, not so we can punish our teams for having an LSI. When you have a 24/7, stuff like that's about to happen. So let's talk about some of the things that we did again in summation here at Microsoft. We went from moving every 3 years to moving every 3 weeks. And that is only where we are today. That is not where we want to be. We will continue to move faster and faster as technology enables us. Now that we have Windows containers, there's going to be a lot more containers used inside of the orchestration and the architecture of VSTS that's going to allow us to move and deploy even faster than we do today. We had to go from a boxed product that you installed yourself to something that runs 24 hours a day, 7 days a week, all across the world. You simply cannot take that down. You will never see a "we'll be right back, we're updating VSTS" message. We literally deploy VSTS while it's running and you're using it, and you never feel the pain. It never errors out because we're deploying it. The worst case scenario is something that used to take you 3 milliseconds will take you 1 second, but it will not error. You will not have to retry it. It will simply work. How did we do that? You can't just do that with any software. The software had to be re-architected such that we could deploy it the way that we do and at the rate that we do. Do not take from this talk that all we did is got the right tools in place. We have this cool DevOps pipeline, so now we can do all this amazing stuff. We had to go back in and rewrite portions of our application such that we could deploy it at the speed in which we want to deploy it. So don't think it's just about tools. It's not just about automation. Your architecture also has to enable your ability to move at the speed in which you want to move. We no longer had a QA team, but we are very, very unique. We are a group of developers writing software for developers. We are our own first customer. So you don't need a whole team of manual testers when for the first 48 hours of any deployment, the team that actually wrote the software is also using the software to do their job for the next 48 hours. We are our own manual testers. Now, some question I get is, but do you test every part of it when you're using it in the 48 hours? Absolutely not. We use Git inside of the VSTS team, which means TFVC is not tested at all, which is our second version of source control. But when it goes to Ring 1, to all of our friendlies and our MVPs, they actually do use TFVC, and that's where we start to get some of that testing. But what about performance issues? That's why we go to Ring 2 in Brazil, where we actually have live customers, and we can start to look at our telemetry and determine if we actually have any performance issues that we need to go and address. And during that process of safe deployment, we're able to make sure that we only put out software that's safe and at a rate that's safe for us as well. We moved from from functional testing over to unit testing, which is crucial for us to, again, move at the speed in which we want to move. The final thing I want to talk about is our deployment principles. You cannot take the service down. That is one of our principles. There is 0 downtime allowed. You have to fully automate your deployment to do that. Never, ever, ever send human beings to do a machine's job. And when you have human beings copying files during your deployment, that is exactly what you're doing. I bet you can track down every deployment failure you had to something a human being did wrong. So stop letting them touch your 0s and 1s. No 0s and 1s should be harmed in the deployment of your software. And you can only do that if you don't let human beings touch them, okay? So take our word for that. We also had to have a joint ownership between engineering and operations. This is not throwing stuff over the wall. This is the two teams coming together and owning the pipeline. If you wrote it, you run it. If there's a live site incident, we all wake up and we all address it. That team gelling together was crucial for us. And the final thing that we use is feature flags, which is really, really important. Feature flags allow us to turn off the part of our system that's causing the issue without having to reboot the server, without having to roll back anything. You simply turn the feature off, do your root cause analysis, push out a fix, and then turn the feature back on again. There is technical debt with feature flags, but it's a small price to pay for the agility that it gives us here at Microsoft. There's a course or in a channel that we have called Channel 9, and I have interviews with all the people who are working on this team So if you want to know more about the ins and outs of feature flags, how we do safe deployment, how we transition to quality, you can go to Channel 9 and just search for me. And it's a show called DevOps Interviews that will give you great details on all this. Unfortunately, we are out of time, but Abel and I will go to the Microsoft booth and we will answer any questions that you have. Thank you so much, everyone.